Some tractors plowed fields and faded into history. Others were so unusual, so ahead of their time, or so downright strange that they defied every rule farmers understood about agricultural machinery. Today, we're counting down 12 unknown tractors you've never heard about, from enclosed cabs with radios in 1938 to machines that started with shotgun blanks and blowtorches. These forgotten legends prove that sometimes the strangest ideas create the most memorable machines. Number 12. Moline Universal Model D. Starting our countdown at number 12 is a machine that put the driver in the strangest position imaginable. The Moline Universal Model D arrived between 1917 and 1923 with a 4-cylinder gasoline engine, generating approximately 20 horsepower through a 2-speed transmission. With the driver sitting in front of the engine and implements mounting behind, this odd configuration created something genuinely unusual that farmers rejected almost immediately, ensuring the Model D's place in history as one of agriculture's most bizarre experiments. The Moline Implement Company faced a genuine challenge entering the tractor market dominated by established manufacturers. The Universal represented their attempt at innovation through unconventional design rather than competing directly against proven configurations. The strategy prioritized differentiation over practicality, creating something memorable for entirely wrong reasons. The 4-cylinder gasoline engine displaced modest cubic inches, generating adequate power for light farm work. 20 horses seemed reasonable for small operations, requiring versatility over brute force. The 2-speed transmission provided basic gearing, allowing operators to match ground speed to conditions, though the limited ratios restricted flexibility significantly. The driver position created the real strangeness. Sitting ahead of the engine meant occupying space normally reserved for front wheels and steering mechanisms. The configuration placed operators dangerously close to implements during operation while providing excellent visibility of absolutely nothing useful. Mounting implements behind the operator seemed logical until attempting any adjustment requiring reach or leverage. The handling characteristics proved awkward and unpredictable. The weight distribution with driver ahead of engine created balance issues affecting stability. Steering required unusual effort and provided minimal feedback. The complete package felt wrong in ways farmers couldn't articulate, but absolutely recognized immediately upon first operation. Today, Moline Universal Model D survivors represent cautionary tales about innovation for innovation's sake. These machines proved that sometimes conventional designs become conventional because they work better than alternatives, regardless of how clever those alternatives seem initially. The Model D's quick discontinuation demonstrated that farmers valued proven functionality over unusual configurations, promising dubious advantages. Number 11. Eagle 6x6 Tractor. Moving up to number 11 brings a machine that applied military thinking to agricultural applications. The Eagle 6x6 tractor arrived during the 1940s with a 6-cylinder gasoline engine generating approximately 60 horsepower through gear drive transmission. With all 6 wheels driven for maximum traction, this military-style machine represented overkill for most farming operations, while creating something genuinely impressive for specialized applications requiring extreme capability. The 1940s saw surplus military technology flooding civilian markets as manufacturers sought peacetime applications for wartime innovations. The Eagle 6x6 adapted military all-wheel drive systems for agricultural use, creating something powerful and capable that most farmers would never need or afford. The 6-cylinder gasoline engine provided smooth power delivery across broad RPM ranges. 60 horses represented substantial output for the era, creating capability exceeding typical farm requirements significantly. The multiple cylinders ensured smooth operation without the vibration characterizing smaller engines, working harder, generating less power. The inline configuration allowed for straightforward maintenance access, with spark plugs, distributor, and carburetor positioned for relatively easy servicing compared to V configuration alternatives. The longer crankshaft with more main bearings distributed loads more evenly, reducing wear and extending engine life under sustained heavy pulling that characterized agricultural service. The 6-cylinder design provided power pulses overlapping more smoothly than 4-cylinder engines, creating nearly vibration-free operation that reduced operator fatigue during long workdays. The engine's torque curve remained flat across wider RPM ranges, allowing operators to maintain pulling power without constant gear changes as loads varied throughout field operations. Fuel consumption remained reasonable despite the additional cylinders, with the engine's efficiency under load offsetting the displacement penalty compared to smaller power plants. The robust construction with heavy castings and substantial bearings reflected military specification durability standards, ensuring reliability under conditions that would destroy lighter agricultural engines quickly. The six-wheel drive system distributed power across 3 axles, creating traction advantages in challenging conditions where conventional two-wheel drive tractors struggled completely. The additional complexity came with weight penalties and maintenance requirements that offset advantages for typical farming operations conducted on reasonably firm ground. Production remained intentionally limited by high costs and specialized nature. Very few Eagles were built, creating instant rarity that has only intensified over decades. Finding survivors becomes increasingly difficult as these machines disappeared into agricultural operations where they worked until worn completely beyond economical repair. Today, Eagle 6x6 survivors represent fascinating footnotes in agricultural history. These machines proved that military technology could adapt to farming applications, even when economic realities made widespread adoption impossible. The Eagle demonstrated capabilities most farmers would never exploit, while creating legend that refuses to fade despite extreme rarity. Number 10. Schluter Super 1500 TVL. Reaching double digits at number 10 sits the German giant that looked like nothing else. The Schluter Super 1500 TVL arrived during the 1970s with a 6-cylinder diesel engine generating approximately 140 horsepower through gear drive transmission. With boxy styling and oversized proportions, this European machine represented a different approach to tractor design that emphasized capability over conventional aesthetics, creating something powerful and unusual that remained largely unknown outside Europe. Schluter operated as a small German manufacturer building tractors for specific markets, valuing raw capability over mass market appeal. The Super 1500 TVL represented their largest offering, creating machines that delivered serious power wrapped in appearance, suggesting industrial equipment rather than refined agricultural machinery. The 6-cylinder diesel engine displaced substantial cubic inches, generating 150 horses through proven technology. The power arrived smoothly across a broad power band, providing thrust adequate for heaviest fieldwork without excessive stress or drama. The diesel fuel economy provided operating cost advantages, offsetting higher initial purchase prices. The boxy styling created a distinctive appearance that either appealed or repelled without middle ground. The oversized proportions suggested capability, and the specifications absolutely justified. Everything about the Schluter announced serious intentions, without concern for aesthetic refinement or market trends favoring sleeker profiles. Production remained limited to European markets, where Schluter maintained dealer networks and parts support. Very few examples crossed the Atlantic, creating near-total obscurity in American agricultural markets where John Deere and International Harvester dominated completely. The Schluter remained a German secret most American farmers would never encounter or consider. Today, Schluter survivors represent German engineering applied to agricultural applications, with different priorities than American manufacturers emphasized. These machines proved that capability and reliability mattered more than styling or market appeal when building equipment for serious farmers, valuing function over form absolutely. Number 9. Field Marshal, Series 1. Breaking into single digits at number 9 is the British machine with the most unusual starting method ever conceived. The Field Marshal Series 1 arrived between 1945 and 1953 with a single-cylinder diesel engine, generating approximately 40 horsepower through a 3-speed transmission. Started with a shotgun blank cartridge igniting the cylinder, this unusual machine combined primitive simplicity with genuinely clever engineering, creating something memorable for entirely unique reasons. British agriculture emerged from World War II facing equipment shortages and limited resources for rebuilding. The Field Marshal represented an affordable solution, emphasizing simplicity and durability over sophistication or refinement. The single-cylinder design minimized complexity, while the unusual starting method eliminated expensive electric starters. The single-cylinder diesel engine displaced massive cubic inches, generating 40 horses through one enormous piston. The power delivery created a characteristic thump, thump, thump rhythm that announced field marshals from miles away. The simplicity meant fewer components failing and easier repairs when problems inevitably emerged from hard agricultural service. The massive piston stroke measured several inches in length, creating enormous torque at low RPM that suited heavy pulling applications perfectly without requiring high engine speeds. The single cylinder's firing impulse, creating the distinctive sound that became synonymous with British post-war farming and could be heard across entire valleys. The flywheel weighed several hundred pounds, storing rotational energy between power strokes to smooth out the pulsating power delivery and maintain momentum through compression cycles. The engine ran at extremely low RPM compared to multi-cylinder alternatives, with typical operating speeds around 500 to 700 revolutions per minute, reducing wear and extending component life dramatically. The fuel injection system used simple mechanical pump and nozzle, requiring no electricity or complex timing mechanisms, ensuring reliability under conditions where sophisticated systems would fail completely. The air-cooled design on some variants eliminated radiators, water pumps, and freeze-up concerns, though liquid-cooled versions also existed for applications requiring sustained heavy loads, generating excessive heat. The shotgun blank starting system created the real uniqueness. A blank cartridge inserted into special chamber ignited, spinning the flywheel through explosive force. The momentum turned the massive piston compressing air until diesel fuel ignited, starting the engine without electric starter, battery, or associated complexity. The system worked brilliantly when everything aligned properly and frustrated completely when conditions weren't perfect. The 3-speed transmission provided adequate gearing for fieldwork and road transport. The ratio spread reasonably across the power band, though gaps between gears sometimes left operators wanting intermediate options. The simplicity meant reliable operation and straightforward repairs when problems emerged. Today, field marshal survivors represent British agricultural ingenuity applied to post-war constraints. These machines proved that sometimes unconventional solutions create workable alternatives when conventional approaches remain unaffordable or unavailable. The shotgun blank starting system remains one of agriculture's most unusual innovations, creating legends that refuse to fade despite the machine's extreme simplicity. Number 8. Eicher ED16. Claiming position 8 is the compact German machine built for specialized applications. The Eicher ED16 arrived during the 1950s with a 2-cylinder diesel engine generating approximately 16 horsepower through a 6-forward, 2-reverse gear drive transmission. Designed as a compact orchard tractor, this small German machine delivered adequate power wrapped in dimensions, allowing operation where larger tractors couldn't physically fit, creating a specialized solution for orchards and vineyards requiring careful navigation. German agriculture included substantial orchard and vineyard acreage, requiring equipment sized appropriately for tight spacing between trees and vines. Eicher recognized this specialized market niche, building compact tractors emphasizing maneuverability over raw power, creating machines perfectly suited for applications where size mattered more than horsepower. The 2-cylinder diesel engine provided smooth power delivery for its displacement. 16 horses seemed modest until considering the applications requiring compact dimensions, rather than maximum output. The diesel fuel economy provided operating cost advantages important for operations running equipment continuously through growing seasons. The 6-forward, 2-reverse transmission provided excellent gearing flexibility for varied applications. The multiple forward ratios allowed operators to match ground speed precisely to tasks, whether cultivating, spraying, or transporting materials. The 2 reverse gears enhanced maneuverability in confined spaces where backing and repositioning occurred frequently. The compact dimensions defined the Eicher's purpose completely. The narrow track width allowed passage between closely spaced trees and vines where standard tractors couldn't operate. The reduced weight minimized soil compaction, important for maintaining healthy root systems. Everything about the ED16 prioritized specialized capability over general-purpose flexibility. Production remained limited to European markets, where orchards and vineyards created demand for compact specialized equipment. Very few examples reached American markets, where orchard operations typically employed different equipment configurations. The Eicher remained a European solution for European applications, creating obscurity in American agricultural consciousness. Today, Eicher ED16 survivors represent specialized European agricultural engineering. These machines proved that sometimes less power packaged appropriately creates more capability than excessive horsepower delivered through inappropriate dimensions. The compact German tractor demonstrated that matching equipment to application mattered more than maximum specifications. Number 7. Rumely Oil Pull. Surging into position 7 is the machine with the strangest cooling system ever designed. The Rumely Oil Pull arrived between the 1910s and 1930s, with kerosene-powered engines generating between 20 and 40 horsepower through gear drive transmissions. Using an oil cooling system instead of water, this unusual machine combined primitive technology with genuinely clever engineering, creating something reliable and effective that looked completely different from every competitor's offerings. The advanced Rumely company faced genuine challenges competing against established manufacturers. The oil pull represented their differentiation strategy, creating tractors using fundamentally different approaches to solving common problems. The oil cooling system eliminated freezing concerns while providing effective temperature management under sustained heavy loads. The kerosene-powered engines displaced substantial cubic inches, generating adequate power for period applications. 20 to 40 horses represented reasonable output for machines intended for belt work and heavy pulling, rather than high-speed field work. The kerosene fuel provided cost advantages over gasoline, while delivering adequate performance for intended applications. The oil cooling system created the real innovation. Instead of water circulating through jackets around cylinders, oil performed cooling duty while simultaneously lubricating moving components. The system eliminated freezing problems, plaguing water-cooled engines during cold weather, while providing effective cooling under sustained loads, generating tremendous heat. The oil capacity required monitoring and periodic changing, but eliminated antifreeze and freezing concerns completely. The gear drive transmission provided direct power delivery without complexity. The limited speeds suited applications requiring sustained pulling power rather than transport flexibility. Everything about the oil pull emphasized durability and reliability over sophistication or refinement, creating machines that worked continuously under brutal conditions. The unusual appearance created a distinctive presence. The massive oil reservoir dominated the profile, announcing the oil pull's different approach unmistakably. The overall design suggested industrial equipment rather than refined agricultural machinery, appealing to farmers valuing function over form absolutely. Today, Rumely Oil Pull survivors represent agricultural innovation from an era when different approaches competed rather than converging towards similar solutions. These machines prove that oil cooling worked effectively, despite everyone else choosing water, creating legends that collectors prize for their unusual engineering and proven durability. Number 6. Hart-Parr 30. Breaking into the top half at number 6 is the machine from one of America's pioneering tractor companies. The Hart-Parr 30 arrived between 1918 and 1926, with a 2-cylinder gasoline engine generating approximately 30 horsepower through a 3-speed transmission. From the company that literally invented the word tractor, this machine represented early agricultural mechanization, when horse farming still dominated American fields, creating historical significance exceeding its modest specifications. Hart-Parr built America's first practical gasoline traction engine in 1901, establishing themselves as agricultural mechanization pioneers. The 30 represented their continued development through the 1920s, creating reliable machines that convinced skeptical farmers to abandon horses for mechanical power. The 2-cylinder gasoline engine provided adequate power for moderate farming operations. 30 horses represented substantial capability for the era when most farmers still relied completely on animal power. The 2-cylinder design minimized complexity while providing smooth power delivery compared to single-cylinder alternatives, creating excessive vibration. The 3-speed transmission offered basic gearing flexibility. The ratios allowed operators to match ground speed to applications, whether plowing, harrowing, or transporting equipment between fields. The limited speeds reflected an era when rapid transport mattered less than sustained pulling power. The construction emphasized durability over refinement. Heavy castings and substantial components ensured longevity under brutal agricultural service. The design reflected understanding that farmers needed equipment working reliably through seasons, rather than sophisticated machines requiring constant attention or specialized repairs. Production ceased as Hart-Parr merged with other companies, forming Oliver Farm Equipment, ending independent production from the company that invented the tractor concept. The merger eliminated the Hart-Parr name even as their engineering influenced the industry they helped create. Today, Hart-Parr 30 survivors represent agricultural mechanization's pioneering era. These machines proved that gasoline power could replace horses economically and reliably, convincing skeptical farmers to embrace mechanization that would transform agriculture completely within decades. The Hart-Parr's historical significance exceeds its modest specifications, creating collector interest in surviving examples. Number 5. Eagle Hitch Case SC. Claiming position 5 is the machine that introduced Case's hydraulic revolution. The Eagle Hitch Case SC arrived during the 1940s and 50s with a 4-cylinder gasoline engine generating approximately 25 horsepower through a 4-speed transmission. Introducing Case's revolutionary Eagle Hitch hydraulic system, this machine transformed implement attachment and control, creating advancement that would influence agricultural equipment for decades, while remaining relatively unknown compared to Case's more famous offerings. Case faced competitive pressure from John Deere, International Harvester, and other manufacturers introducing hydraulic systems that simplified implement attachment and control. The Eagle Hitch represented Case's response, creating a system that worked differently than competitors' offerings while delivering similar benefits. The 4-cylinder gasoline engine provided smooth power delivery adequate for small to medium farming operations. 25 horses represented reasonable output for row crop applications, where maneuverability mattered as much as raw power. The engine operated reliably under sustained loads without excessive maintenance requirements. The 4-speed transmission offered good gearing flexibility for varied applications. The ratios spread adequately across the power band, allowing operators to match ground speed to conditions and implements. The additional gear, compared to 3-speed alternatives, provided welcome flexibility for transport and field work. The Eagle Hitch hydraulic system created the real innovation. The 3-point attachment with hydraulic control allowed operators to raise and lower implements from the seat rather than manually cranking mechanical lifts. The system maintained implement depth automatically through draft control, sensing soil resistance and adjusting hydraulics accordingly. The advancement transformed fieldwork efficiency while reducing operator fatigue significantly. Production remained more limited than Case's mainstream models, creating relative rarity that has intensified over decades. The SC with Eagle Hitch represented advancement many farmers recognized and appreciated even as they purchased other Case models, offering similar capabilities with different hydraulic systems. Today, Eagle Hitch Case SC survivors represent Case's contribution to the hydraulic revolution that transformed agriculture. These machines proved that multiple approaches could solve similar problems effectively, creating competition that benefited farmers through rapid advancement and improved capabilities across all manufacturers' offerings. Number 4. Cletrac Model F. Breaking into metal contention at number 4 sits the compact crawler that proved tracks belonged in agriculture. The Cletrac Model F arrived during the 1920s with a 4-cylinder gasoline engine generating approximately 20 horsepower through gear drive transmission. As a compact crawler tractor instead of wheeled machine, this unusual design demonstrated that tracked vehicles could work effectively in agricultural applications, creating a niche following among farmers working challenging terrain where conventional tractors struggled completely. The Cleveland Tractor Company pioneered agricultural crawler tractors, adapting military and industrial track technology for farming applications. The Model F represented their compact offering, creating machines sized appropriately for small operations or specialized applications, requiring crawler advantages without full-size dimensions. The 4-cylinder gasoline engine provided smooth power delivery, adequate for the Model F's size and intended applications. 20 horses represented reasonable output for compact crawler working challenging terrain, where traction mattered more than speed. The engine operated reliably under sustained loads, characteristic of crawler operations. The gear drive transmission delivered power directly to track drives without complexity. The limited speed suited crawler applications, emphasizing pulling power over transport flexibility. Everything about the drivetrain prioritized sustained effort, rather than versatility or speed. The track design created the real advantage. The continuous tracks distributed weight across larger surface area compared to wheels, reducing ground pressure and minimizing soil compaction. The tracks provided superior traction on soft or uneven ground, where wheeled tractors bogged down or slipped wheels uselessly. The crawler configuration excelled in applications where terrain challenged conventional equipment completely. The compact dimensions enhanced maneuverability despite the track design. The Model F could navigate tighter spaces than larger crawlers while maintaining track advantages over wheeled alternatives. The size suited small operations or specialized applications, where full-size crawlers proved excessive. Today, Cletrac Model F survivors represent early agricultural crawler development. These machines proved that track designs offered genuine advantages for specific applications, even as wheeled tractors dominated mainstream farming. The compact crawler demonstrated that niche markets existed for specialized equipment, serving needs conventional machinery addressed inadequately. Number 3. Lanz Bulldog. Surging into the bronze medal position is the German machine with the strangest starting method and engine design. The Lanz Bulldog arrived between 1921 and 1955 with a single-cylinder hot bulb engine generating between 30 and 50 horsepower through a 3-speed transmission. Started with a blowtorch preheating system. This unusual machine combined primitive simplicity with proven reliability, creating something genuinely different that dominated German agriculture for decades, while remaining largely unknown in American markets. German engineering approached agricultural mechanization differently than American manufacturers, emphasizing simplicity and fuel flexibility over sophistication. The Lanz Bulldog represented this philosophy completely, creating machines that ran on almost any petroleum distillate while requiring minimal maintenance under brutal service. The single-cylinder hot bulb engine represented a fundamentally different design than conventional gasoline or diesel engines. The hot bulb design used a semi-diesel combustion process, where fuel injected into a preheated chamber ignited through compression and retained heat rather than spark ignition or precise diesel injection timing. The system ran on kerosene, diesel, vegetable oil, or almost any combustible liquid, providing fuel flexibility valuable when supplies remained uncertain. The starting procedure created a memorable experience. Operators used blowtorch heating the bulb until glowing red-hot. Once properly heated, fuel injection and compression ignited mixture, starting the engine with characteristic thump announcing Bulldog operation unmistakably. The procedure required patience and experience, frustrating novices while becoming routine for experienced operators. The power output varied across production spanning over 3 decades. 30 to 50 horses represented a reasonable range for machines sized appropriately for European farming operations, typically smaller than American counterparts. The single cylinder created a distinctive rhythm, announcing bulldogs from miles away. The 3-speed transmission provided adequate gearing for fieldwork and transport. The ratio suited European farming patterns, emphasizing versatility over specialized high-speed capabilities. Everything about the Bulldog prioritized reliability and simplicity over sophistication or refinement. Production continued for 34 years, creating millions of Bulldogs that dominated German agriculture. The design's simplicity ensured longevity and easy repairs, using minimal tools and limited technical knowledge. Farmers valued reliability and operating economy over modern conveniences or refined operation. Today, Lanz Bulldog survivors represent German agricultural engineering philosophy, emphasizing different priorities than American manufacturers pursued. These machines prove that simplicity and fuel flexibility created genuine advantages outweighing conveniences. Sophisticated engines provided, creating legends that collectors worldwide seek and preserve. Number 2, Fordson F. Claiming runner-up honors is the machine that brought affordable mechanization to millions. The Fordson F arrived between 1917 and 1928 with a 4-cylinder gasoline engine generating approximately 20 horsepower through a 3-speed transmission. As one of the first mass-produced tractors in the world, this machine transformed agriculture globally by making mechanical power affordable for ordinary farmers rather than only wealthy operators, creating a revolution that changed farming forever. Henry Ford applied automotive mass production techniques to tractor manufacturing, creating machines affordable for farmers who couldn't justify expensive equipment. The Fordson F represented his vision of mechanization for everyone, selling for prices undercutting competitors dramatically while providing adequate capability for typical farming operations. The 4-cylinder gasoline engine displaced modest cubic inches, generating adequate power for small to medium operations. 20 horses represented reasonable output for a machine priced affordably, rather than emphasizing maximum capability. The engine operated reliably when maintained properly, though the design included quirks requiring understanding and attention. The 3-speed transmission provided basic gearing flexibility, adequate for varied applications. The ratios allowed operators to match ground speed to implements and conditions reasonably well, despite limited options compared to later developments. Everything about the drivetrain emphasized adequacy over excellence, creating workable solution at an affordable price. The construction prioritized cost reduction over durability. Lightweight components and minimal material usage kept prices low, while creating machines that required more frequent maintenance than heavier competitors. Smart operators accepted trade-offs, recognizing that affordable equipment requiring attention beat expensive machinery beyond their financial reach. The mass production created unprecedented availability. Millions of Fordson Fs sold globally, bringing mechanization to farmers worldwide who previously relied completely on animal power. The affordable pricing democratized agricultural mechanization, creating a revolution that transformed farming from labor-intensive drudgery to mechanized efficiency. Production moved between American and British factories as Ford responded to market conditions and production economics. The global reach ensured Fordsons worked fields from America to Europe to Asia to Australia, creating truly international impact unmatched by any competitor. Today, Fordson F survivors represent agricultural mechanization's democratization. These machines proved that affordable equipment accessible to ordinary farmers mattered more than sophisticated machinery, available only to wealthy operations. The Fordson's historical significance exceeds its modest specifications, creating collector interest in surviving examples that changed agriculture forever. Number 1. Minneapolis Moline UDLX Comfort Tractor. Taking top honors as the most unusual unknown tractor ever built is the machine that tried being car and tractor simultaneously. The Minneapolis Moline UDLX Comfort Tractor arrived between 1938 and 1941 with a 4-cylinder gasoline engine generating approximately 40 horsepower through a 5-speed transmission, with enclosed cab featuring heater, radio, upholstered seats, and 40-mile-per-hour road gear. This machine arrived decades ahead of its time, creating something genuinely revolutionary that farmers rejected completely, ensuring the Comfort Tractor's place as agriculture's most fascinating failure. Minneapolis Moline pioneered numerous tractor innovations, including self-starters, LPG fuel systems, and articulated designs. The UDLX Comfort Tractor represented their most ambitious innovation, creating a machine combining field work capability with automotive comfort and road performance. The concept predicted modern cab tractors by 30 years, while the execution created something too expensive and unusual for Depression-era farmers to accept. The 4-cylinder overhead valve gasoline engine displaced 283.7 cubic inches, generating 41.5 belt horsepower and 37.8 drawbar horsepower at 1,275 RPM. 1,785 RPM became available for road travel through direct drive 5th gear that disabled lower gears and engine governor, allowing speeds reaching 40 miles per hour. The 5-speed transmission represented genuine innovation. The first 4 gears provided field work ratios, while 5th gear created direct drive for road transport. The shift-on-the-fly capability allowed operators to change gears without stopping, creating flexibility unmatched by competitors requiring complete stops for gear changes. The enclosed cab created the real revolution. The all-weather cabin protected operators from elements completely, unprecedented luxury for 1938 when most tractors offered no weather protection whatsoever. The automotive appointments included upholstered seats, heater, radio, cigarette lighter, clock, rear-view mirror, sun visor, windshield wipers, opening windows, and safety glass. The fold-down passenger seat accommodated the farmer's wife, fulfilling marketing promises about driving to town comfortably. The styling suggested Art Deco automotive design rather than agricultural equipment. The streamlined bodywork, painted in prairie gold with chrome bumper and hubcaps, created an appearance suggesting an automobile more than tractor. The flowing lines and enclosed cab looked decades ahead of contemporary agricultural machinery. The rear door entry created awkward access, requiring operators to climb over spinning power takeoff positioned dangerously close to the entry path. The passenger had to fold their seat against the wall during entry before unfolding it for occupation. When pulling implements, the back door remained open, allowing access to trip ropes and control levers, negating weather protection advantages completely. The marketing emphasized dual-purpose capability, working fields during the day, then driving to town in evening comfort. The reality proved different. Farmers struggling through the Depression couldn't justify $2,155 when comparable tractors cost half that amount. The Comfort Raptor cost nearly as much as the new Cadillac sedan, creating financial impossibility for the target market. Production remained extremely limited. Best estimates suggest 150 units built between 1938 and 1941, though some sources claim only 125. Many unsold units returned to the factory, where Minneapolis Moline removed the expensive enclosed cabs and converted machines back to standard Model U tractors, creating even greater rarity among surviving complete Comfort Raptors. The commercial failure proved complete and immediate. Farmers rejected the Comfort Tractor, despite its innovative features and genuine capabilities. The high price, economic conditions, and unusual concept combined, ensuring market rejection that ended production after minimal sales. Minneapolis Moline learned a painful lesson about innovation timing and market readiness. Contemporary reviews praised the innovation while acknowledging commercial challenges. The automotive comfort impressed reviewers accustomed to open tractors offering zero weather protection. The road performance demonstrated genuine capability, though the ride quality remained rough despite the enclosed cab. The overall execution showed genuine engineering excellence, creating something nobody wanted badly enough to justify the cost. Today, UDLX Comfort Raptors represent the holy grail of tractor collecting. Of approximately 150 built, roughly 80 survive, with perhaps 25 restored to roadworthy condition. Clean examples command prices exceeding $200,000 at auction, reflecting extreme rarity and historical significance, exceeding original market value by 100 times or more. The Comfort Raptor predicted modern cab tractors by 3 decades. Every contemporary tractor offers an enclosed, climate-controlled cab with sound systems and comfortable seating, exactly what Minneapolis Moline delivered in 1938. The vision proved correct even as the timing proved disastrous, creating a machine ahead of its era by generation or more. The innovation extended beyond the cab. The 5-speed transmission with road gear, automotive-style controls, and genuine comfort represented thinking fundamentally different from competitors building open tractors, emphasizing raw capability over operator experience. Minneapolis Moline understood that improving operator comfort and versatility mattered even as the market refused to pay the required premium. The UDLX Comfort Raptor proved conclusively that revolutionary innovations require market readiness beyond engineering excellence. The machine delivered everything promised while creating financial disaster through a perfect combination of wrong timing, excessive pricing, and radical departure from accepted practices. The Comfort Raptor taught the industry that innovation must match market conditions or fail regardless of technical merit. These 12 machines proved that agricultural innovation took many forms, some successful, others failures, but all memorable for departing from conventional wisdom. They started with blowtorches and shotgun blanks. They cooled with oil instead of water. They enclosed operators when everyone else left them exposed. Some transformed agriculture, while others faded quickly into obscurity. But every single one created legends that refused to die because they dared to be different when different seemed impossible. Which of these forgotten machines would you resurrect? Drop your answer in the comments. And if you love stories from agriculture's most innovative era, hit subscribe for more tales of tractors that changed everything or failed trying.